Okay, my clock says that it's straight up 12 noon. I'd like to welcome everybody to the Iowa State University Extension and Outreach Dairy Team Monthly Dairy Webinar Series. We continue today with Dr. Adesogan, Professor of Ruminant Nutrition at the University of Florida. I remind everyone that questions can be typed into the chat box, and we will address the ones that Dr. Adesogan didn't get to during the program at the end of his presentation. Please note that this presentation is recorded and archived on the Iowa State University Extension and Outreach Dairy webpage. And finally, please take a couple of minutes to complete the evaluation after the program, and I will have that link provided in the chat box. As we've seen this year, southern rust is an aggressive disease caused by polysora fungi that can destroy a crop or at least severely damage it in just a few days. Dr. Adesogan's research aimed to determine the effect of the level of southern rust infestation of a corn hybrid on silage fermentation, nutritive value, and bunk life, and determine how inoculant application affects these measures of forage quality. In addition to being a professor of ruminant nutrition at the University of Florida, Doc is director of the Global Food Systems Institute and the director of strategic partnerships for the Feed the Future Innovation Lab for Livestock Systems. His research focuses on sustainability, increasing animal source food production and consumption, improving forage production, quality, and preservation, and using feed additives, forages, and byproducts to sustainably improve animal production and health. As I always say, Dr. Adesogan, the podium is yours.
Thank you. Thank you very much, Fred. Ladies and gentlemen, thank you for joining us today. It's been a privilege over the decades to work with people like Dan Undersander and Rich Mock, and I've learned a lot from them. And I'll ask you to please bear with me because my voice may get a little hoarse. I had throat surgery to remove half of my thyroid last week, so I'm grateful to the good Lord that I can speak to you. I want to acknowledge my co-author, Max Chibogu, who is in plant pathology there at UW-Madison with you. Okay, so we're going to jump right in and start off by talking a little bit about rust in cereals, the history, the background, the symptoms. We'll share a little bit about the life cycle, and then we'll zero into rust and corn silage. We'll talk about the study that we did that Fred referenced, talk about some management considerations, and then some take-home messages. So as we all know, rust is a devastating plant disease, and within a very few days, it dries the crop, it damages the leaves and the stems. You have the spores forming these bright orange pustules all over the leaves and the stems, decreases the growth and the yields. It makes the crop less digestible, and within a couple of weeks, it can kill the crop. And of course, I couldn't find any data on the global economic importance for corn, but for other crops like wheat and coffee, it runs into the billions. Now, if we dial down to the history, for millions of years, rust has been a problem and it's caused very terrible crop losses, up to 80% crop losses. And for the most part, it has been a tropical, subtropical disease. So when I started at Florida 24 years ago, we had southern rust in Florida and the southeast, and you all had common rust up in the Midwest. but now things are changing. And over the decades, the main strategies in the early days, the strategy was to remove host or reservoir plants that the pest can grow in. But now the focus is more on fungicides and resistant varieties. The challenge we face is that rust evolves so quickly that no sooner do you have some resistant strains and varieties to use that you have a new variant that is making it a problem to grow corn in areas where you grew it before, or is spreading into new areas. And as far as southern corn is concerned, it was first discovered in Alabama in the 80s. And as I mentioned, they found a variant that was defying the resistant hybrids and causing diseases back in the 2000s. But even until maybe 10 years ago, even 5 years ago, it was largely confined to the Southeast. But the challenge has been the temperatures, the high temperatures that we've had in the last few years, particularly in the last 3 years. And this year, certainly in Florida and other parts of the US, we've seen some of the highest temperatures on record. This was an article that USDA put out in 2023, and they were essentially warning everyone that warming temperatures in the Corn Belt will continue into the next decade. And they said that both the growing degree days, which are how much beneficial temperature you have during the day, and the extreme degree days, which refers to temperatures in excess of 30 Celsius or 86 degrees Fahrenheit. Both of those, we're seeing more of those in the last few years. And you can see this yellowish bar curve here for 23 is the furthest to the right, which shows that these temperatures have been rising, and that trend has continued. And when you take that trend and you couple it with the dry conditions that we have been facing in many parts of the country, in the Midwest, thankfully the drought conditions we feared in May did not persist, but still we've had very, very dry conditions, so much so that Eric Snodgrass, who many of you probably know, mentioned that the corn in the Midwest did not dry down, it died down, which is very sobering. So we have dry conditions, we have started to put our silage up, and what can we expect if we've had rust? The thing about rust is a lot depends on the level of infestation, which itself depends on how early it affects the crop. So we'll come back to that in a minute. Now, there are different types of rust for different types of crops, coffee and wheat and so on and so forth. But what we're concerned most about today is common rust, which is the Puccinia polysora. The common rust you're more familiar is Puccinia sorghum, and that has darker spores relative to the more orange, bright orange spores that we have with southern rust. And when it's mature, these orange areas, it doesn't look so orange in this picture, it will in the next slide, they become black. And there can be on top of the leaf, under the leaf surface.
So if he got a chance, he was going to talk to them.
Okay. And so if we look here, typically the southern rust is confined to tropical, subtropical temperatures. So about 70, 80 degrees, 90 degrees temperature ranges. Upper leaf surfaces, orange, you can see the coloration compared to the common rust. And then also it's much more densely present on the leaf surfaces than the common rust. And that's one of the reasons why it's so devastating, because it's so dense on the leaf surface. It's spread obviously in the air. It's unpredictable, although I'll show you some work that is being done that's trying to predict the incidence of rust, and it's very aggressive. And what it does is that it saps the nutrients and it makes the plant dry off prematurely, close the stomata so that the plant can't take in carbon dioxide, it can't give out oxygen, it kills the leaves, causes stalk rot, it causes lodging and eventual crop failure. And this can happen within a week. Um, so traditionally, we would have said Florida, Georgia, southeastern areas are the areas where we have this. But with the high temperatures we're facing in other parts of the country in the Midwest, it's becoming a challenge. So from the southern US, the southeast, and from Mexico, the spores are blown in from June until July. And then under those high temperature and humidity conditions, they get on corn plants and they start to grow and they multiply, they spread throughout the corn plant and cause their devastation. They usually don't overwinter, except in few cases. So most of the time they die and you have to have a fresh crop that is blown in that makes the problem persist into the next season. So that's the life cycle. Now let's talk about the effects. First of all, it causes premature maturity. I won't call it early maturity. The picture here is like a worst case scenario. And by the time it gets to this stage, it's too far gone. But it makes the plant drier. It makes it lignified, which means it reduces the digestibility. It makes the cell wall, it's almost like using cement to strengthen and harden the cell walls, making it much more difficult for the cow to digest. It reduces yields, grain weight, it causes death, and it also makes the plant much more susceptible to mycotoxins. It can also reduce intake in animals. And so this is some data for common rust, and I couldn't find any similar data for southern rust, but I guess it's going to be very similar. So this is some early data showing that the damage, the dryness, and the digestibility loss depend on when the infection first occurs, the time, the month, the date, the age of the crop at that time, and the weather conditions, whether you continue to have those hot, humid conditions. And then they went on to say that the yield loss depends on the death time and how much plant damage you have. So if you have only 1% of yield loss per day, that would occur if plants die 15 days prematurely. If they die 5 days prematurely, then you are looking at 2% yield loss. And if death occurs 2 weeks prematurely, then 20 to 25. So it can be pretty severe. And this just shows the importance of catching it early, applying those fungicides early, and even going in with the rust-resistant hybrids from the get-go. Now, this study I'm going to share with you is over 20 years old, but I think it's still very applicable. We wanted to know how the level of southern rust infestation affects the nutritional value, the fermentation, and the bunk life of corn silage. And we also wanted to see if a bacterial inoculant could reverse some of the adverse effects of the rust on the corn silage. So we were kind of, I don't know if fortunate is the right word, but a crop duster had applied a fungicide to a field of corn. And as it happens sometimes, the coverage was not uniform. And so there were some parts of the field with no rust, and there were other parts with very extensive rust damage. And that we then classified the field into areas with no damage, which we called clean, or medium rust damage, or high rust damage. And these are pictures that we took. So this would be corn from the area where the corn duster was very effective. It covered the area well, and so there's no rust. Then there were areas where there was only partial coverage, And you can see that about halfway up the plant, the rust is evident. And then finally, we have areas where the crop duster seemed to have missed the area completely, or maybe the application rate was wrong and the plant was literally gone. And so these were our 3 treatments. We harvested the silage from the silage corn from each of these 3 parts of the field, and then we treated it with or without an inoculant. And so we had clean corn with clean, medium, or high corn without the inoculant, or clean, medium, or high corn with the inoculant. This was all ensiled in mini silos. The inoculant was from Lallemand Animal Nutrition. It's a Buchneri inoculant, which has a pediococcus for the front end of the fermentation, improving the fermentation, and has Lactobacillus buchneri. The name has changed, but we don't need to bother with that for now. For the back end, for bunk life. So this is what we found. First of all, this is how the corn rust, how the rust affected the standing corn. The first thing we noticed was our dry matter percentages were much higher for the high rust. That was evident to the eye, that we could see that. But what we also saw that the fiber content, the NDF, was much, much higher. And then the digestibility of the dry matter, this is the total dry digestibility, was lower for the high rust. Remember, these crops were all grown at the same time, harvested at the same time. So this effect here is not a maturity effect, it's a rust effect. Okay. We found no mycotoxins in the fresh corn forage. Then after ensiling, we looked at those parameters as well, and let me explain how this graph is laid out. So on the x-axis here, we have the clean, which means there was no rust at all, and you have the white bar, which is the control, and then the green, which is the inoculant. Then we have the medium level of rust infectation. The control is the white bar, and then the green is the inoculant. And then with the high rust, we have again the control and we have the green. So what you can see here, if you look across the 3 stages of rust infestation, you can see there is a dramatic increase in dry matter concentration. So the moisture was far lower in the high rust treatment, just as we saw in the corn forage. Okay. This is the fiber concentration. Again, you can see a trend towards higher rust, higher fiber concentrations as you have higher levels of rust infestation. So the level of rust, the impact on fiber was greater. There was a tiny trend there for inoculants for higher rust, but that was not significant. Now, this is the digestibility of NDF, which is one of the most important metrics for milk production by dairy cows. And what you see here is if we look at the rust effects, they were lower. The high rust reduced the fiber digestibility very, very greatly, very seriously. And then the inoculant was able to maintain higher levels of NDF digestibility when we had no rust or when we had medium levels of rust. But when we had high levels of rust, the inoculant didn't help. So this is a very important finding because it shows that just depending on the level of rust, the NDF digestibility can be very drastically affected, and that would definitely have implications for milk yield. So in summary, the rust dried the silage, it increases the NDF, it decreased the NDF digestibility, and then the inoculant helped to reverse some of that adverse effect, but only in the clean and in the medium rust, not in the very high contaminated rust silage. Now, if we look at measures effects of rust on the fermentation, First of all, we find a trend for the higher rust silage to have higher pH, which suggests that the fermentation was not as good. Okay. When we look at the lactic acid concentration, the lactate is the primary acid that we are trying to produce during the fermentation. We're trying to get the sugars in the plant fermented into lactic acid. What you have here is as the level of rust increased, there was a linear decrease in the lactic acid concentration. That means that the rust caused a very drastic reduction in the quality of the fermentation. And inoculant application reversed that trend. So the inoculant was protective of the fermentation, which is very interesting. We had never seen that before. And acetate is the second acid that we would like, maybe not as much, it depends on whether we want it for bunk life. If we want it for bunk life, then we want a lot of it. And what you see here is that in medium and high rust, the inoculant really increased the acetate. But again, the rust reduced the acetate levels relative to the control. So the rust, in summary, okay, last point here, the high rust had butyric acid. Butyric acid is when the silage smells rancid, and that will definitely reduce intake by the cows. It causes, it's evidence of a clostridial fermentation, which is one of the worst types of fermentation with very high spoilage losses during the fermentation, and it will reduce intake drastically. So we found very high levels in the high rust. So summary for the fermentation: reduced fermentation, poorer fermentation, and some adverse effects of rust on the fermentation that were reversed by the inoculant. Then finally, effects on yeasts and molds and mycotoxins. I don't think we presented the yeast data, but this is what's more interesting. For the mold data, we had low mold counts, which is good, but that's only because the forage was just so dry that the molds could not grow. So this is not really a benefit. In terms of the bunk life hours, again, we can see that using that inoculant increased, almost doubled the number of bunk life hours of that inoculant. Again, so this is what was very interesting when we looked at the mycotoxins. We found no rust. I think we only looked at the clean and high rust samples. And we found very high levels of aflatoxin in the high rust corn, but only when the inoculant was not applied, only in the control. So we found none when the inoculant prevented aflatoxin production, but this is a big problem. And if we're having rust in the Midwest, this is something we have to watch out for, because aflatoxin is not a common mycotoxin in the Midwest. It's much more common here in the Southeast, in the warmer climates. So this is something to watch out for, because aflatoxin is devastating on cow health. It can also cause problems for people. It can cause reproductive problems, all kinds of issues like that. And then with the zearalenone, we found it's another mycotoxin that affects reproduction in cows. And what we found in this case is a much higher level than the FDA threshold in the clean corn. This was not expected. This is the clean corn. So when you look at the corn, it looked clean, it looked fine, but it had a high level of this mycotoxin. So the mycotoxin results suggest that we need to be very careful with rust infestation in corn, because it can increase zearalenone in clean silages, and with high levels of infestation, it can increase aflatoxin levels. So what is the key? Prevention is the key. And number one is thinking about resistant hybrids. So that's going to be very important as you think about your hybrid. choices for the next season, and then also which fungicide are you going to apply. And what we've found is that the fungicides are effective if you apply them early enough, but the effectiveness decreases with time in the season. So the rust-resistant hybrids will be the number one preventive strategy, coupled with applying a good fungicide. And then using an inoculant can also help to reduce that adverse effect. And I'm not a plant pathologist, so I can't speak on these different options here, but this is a publication from 2022 where they shared some rust inhibiting fungicides that you may want to consider. Now, what I'd like to also mention briefly is, what if you open your silages, you send them to Dairyland or Dairy One, and you notice that you have a high aflatoxin or concentration? Well, we've done studies over the years that have shown that if you add certain clays to the diet, they can bind the aflatoxin and prevent it from exceeding the FDA thresholds, so that the milk is still safe for sale, is safe for your cows, and is safe for people. And so is in these types of studies, we would feed the pure toxin and then remove it on day 0, and then add it back on day 6. And you can see that once we add it on day 6, the control, this is aflatoxin in the milk of cows. There's a spike in aflatoxin. The FDA threshold is 0.5, is here. And you can see a spike beyond the FDA threshold. But in this case, adding the clay prevented the level from reaching the FDA threshold, so that milk can still be sold. Whereas the control milk would have to be dumped. And so clays are good. There are also a number of other products on the market. Clays tend to be very much more effective. You can see these are some activated charcoal products. The clay, another name for clays, is this hydrated sodium calcium aluminosilicates. And this is just showing 100% binding efficacy to a diet that contains 3 parts per billion aflatoxin. So if you have high levels of aflatoxin in the silage or in the diet, there are remedies. You can consider a binder. So Max and the team at the U.S. Dairy Forage Research Center, Dennis Hancock and Dr. Meng, have been working to help us to detect rust much quicker. And so they're working on this using drones with hyperspectral imaging cameras that will allow us to fly a drone over the field. And before we see the pustules on the leaves, they can tell us that there is a rust infestation on the way. So this is good news, and this is something we should look out for. So I'll conclude by saying that southern rust infestation, it can rapidly and very drastically reduce forage quality, yields, and it can worsen the fermentation. It can increase or cause dangerous mycotoxins to be present in the silage and in the diet. Rust-resistant hybrids are vital. Spraying fungicides early. Inoculants can help. Propionic acid is another alternative to bacterial inoculants for silage preservation that would most likely have similar effects. And then mycotoxin binders can be used if you have high levels of aflatoxin. So take-home messages: rust-resistant hybrids, extremely important. Planting date with an agronomist is very important. Discussing the planting and harvest date. Scouting to look out for rust infestation and getting that crop duster into the field as quickly as possible. Applying those fungicides early is vital. Talking to your extension specialist about which fungicide to apply. Then for the silage program, excuse me, an inoculant or prop acid, and then a binder if you have mycotoxins. So with that, I thank you very much for your attention, and I'll be glad to try and take any questions. Thank you.
Thank you very much, Dr. Adesogan. If folks have a question, they can type it into the chat box. We've got about 35 people on. If we be a little respectful, I think we can even go ahead and just unmute yourself and ask the question. I'll give just a few seconds to see if we get any questions from the group. We had a question come in as you were talking. Is there any resistance starting to show up from the fungicides that are currently being used?
That's a very good question. Unfortunately, that's not my subject area, and I can't speak to that. I would encourage you to please contact, the plant pathologist. I don't know, Max, you're a pathologist, so maybe you can speak to this. I don't know if Joe Lawrence has some comments on that. With time, these fungi do develop resistance, but I can't speak to how resistant they are to some of the current fungicides. So, Max or Joe, would you have anything to add? Oh, see,
Yeah, I was going to say, Dr. Allison is also the plant pathologist that can speak to the issue. As for resistance, I'm not aware that there's fungicides that are, because the fungus comes from the south every time, so except the ones that are being used there and it evolves with it, I don't think there's any resistance being developed.
thank you, Max. Dr. Allison, I hear you're the expert here.
I'm not sure about that, but I have not heard of any resistance developing to the fungicides amongst the rest. I think one of the good things about fungicides that are being used on corn for southern rust is they usually contain 2 or 3 mode of action, and so that discourages the rust, or it just makes it harder for the rust pathogen to develop resistance to the fungicide. So along with that thought, there are some generic fungicides that can be bought now to spray against corn diseases. And it's very important that if you're going to use a generic fungicide, to make sure you use generic fungicides from at least 2 mode of action groups, so that we don't need to worry about fungicide resistance developing. Just my thoughts.
Very important points there. And she also mentioned and shared a link to the Plant Disease Network, where you can look at information on the efficacy of different fungicides. So please check that out. The link is in the chat.
Very good. We appreciate that, Allison. Another question was, as we see resistance hybrids being used, are they changing the significance of the rust challenge? Is the rust adapting to those resistant hybrids?
I think the rust is going to adapt. That's the nature of these things. But I think what Dr. Allison was sharing with us is there is no evidence of, or at least she has not seen evidence of resistance to the pesticides for corn so far. But over time, you can be sure that that will happen, hence her caution that we should use fungicides with more than one mode of action. The nature of these things, whether it's the COVID vaccine, the COVID virus or whatever it is that they do mutate over time, they do change, and they do find ways of getting around um, our defense mechanisms in the new hybrids. And I see a question in the chat here there about whether, so Nelson, thank you for joining. Aflatoxin is produced by a fungus. It is produced by a fungus, but a different one, Aspergillus flavus, Aspergillus fumigatus. So that's a soil-borne organism typically, but yes, it's a different fungus from the Puccinia polysora that causes the rust.
It's kind of exciting to have the brain power here in our audience and have this discussion. Do we have other questions?
Yeah, I see something that Max posted here is anything that stresses a plant makes it much more susceptible to aflatoxin contamination. So high temperatures, drought stress, God forbid, lodging, things like that. All those different factors make the plant much more susceptible to the aspergillus, which produces the toxin. So there's a question here for Max. With the drone technology, with the hyperspectral imaging, what would be the early intervention strategy?
So to speak to that, the whole point of that project is to try to see how we can detect early, because most of the times when people apply fungicide, and because um, southern rust or the rust disease is a polycyclic disease, meaning it goes quickly, really fast in the field. Once you have your first infection, the spores reproduce and they spread from leaf to leaf and from plant to plant pretty quickly. So early detection is usually key. And by the time people scout and discover it, it's almost too late for fungicide application to do any much effect. So the whole point is to see how we can use fields that are known or that we had, like this past season that we saw rust develop. We can track those spectral disease indices during the season. And so we can use that to predict, say, okay, other than applying fungicide when it's late, you can then apply it when it's pretty much earlier, when the disease is just about starting and not getting to the point where it's producing enough spores to continue the polycyclic stage. So yes, the the point of the drone technology, hyperspec imaging, in short, will be to allow farmers or growers the opportunity to detect your disease early and apply your fungicides in time to save your yield.
Yeah, and I'm not a plant pathologist or somebody who works with drones, but in my very simple understanding, what those hyperspectral images are, cameras that are attached to the drones that allow you to take aerial photographs from very high elevations. And then you're looking at images that help you detect the rust before it's visible to the naked eye. So they're looking at, it could be physical changes in the plant that we can't detect yet, or it could even be chemical changes that are not yet evident to the eye. So hopefully that will help us to detect the rust a lot earlier, and so we can go in with a fungicide and effect the preventative measures.
Dr. Robinson, thank you very much for putting the disease loss estimates from the Crop Protection Network into the chat there. Appreciate that. We've got a question from Stacy concerning the tar spot. Do you expect any different issues with tar spot?
So I'm not familiar with tar spot. I'm sorry, it's not something I've heard of down here in the South. And maybe I'm sure somebody in the audience would be able to answer that. So please, who would like to share? Dr. Allison, is that something you can speak to?
I'm sorry, would you mind repeating the question? Just I had a text come in that I was answering,
No problem.
and I don't mean to take over your presentation.
That's fine. You can
I
go
was
ahead
just,
and take over. I'm learning a lot.
I was
Um,
here to learn too.
would we
So,
expect, the question is, would we expect any different issue with tar spot?
Um, that's a good question, and Max probably has more experience with working with tar spot than I do. I don't think that tar spot dries down the plant as quickly as southern rust does, but we would still see, we would still see the corn dying prematurely. We would still have an issue with stalk rots and standability. Yeah, so I don't know. Max, have you got any idea?
Yeah, I think tar spot also dries down the plant, but I don't think there's any research that's been done comparing how quickly they both do the drying down. But from what I saw while I was scouting fields this year, it's usually what we see in the fields, both diseases happening or co-occurring at the same time. So tar spot is contributing its own drying down effect. Southern rust is also doing that. So it's very hard, especially late in the season, where you find independent diseases, or you just find a field that's independently just southern rust or just star spot. I mean, most times we have just star spot and a few NCLB here and there, but I would say most diseases work hand in hand to kill the plant. But also to add just a little science knowledge there, as biotrophic organisms or this tar spot and southern rust, they both would prefer the plants to be alive. So they can only survive on living tissues. They wouldn't survive on a dead plant. So their goal, technically, as an organism, is to keep the plant alive while they suck nutrient as fast as they can. But as they do that consumption of nutrients, then the plant quickly dies via other forms of stress too. Yeah.
This is
thank,
Joe. This is Joe Lawrence. If you don't mind a comment, one of the biggest things we haven't had a lot of tar spot in New York yet, but in talking to some colleagues in the Midwest, and what we've seen here is the timing of the infection is really critical to the impact on the forage quality. So, um, and because it does overwinter in the north. As it becomes more endemic in certain areas, it's more likely to have earlier infections in the season. So when we see later infections into late August or September, as we have so far here in New York, there's really very little impact on yield or quality, but there is documentation from the Great Lakes and Midwest of earlier season infections that um, in addition to decimating yields, can have been documented to have a negative impact on fiber digestibility.
thank you, Joe. Mike asked, are there any signature soil types or the key signature soil measurements that lead to rust infection?
Oh. I Not that I know of. I suspect that there might be a relationship in that more sandy soils that don't hold as much moisture, you'd probably that the rust fungus would have more of an impact there. The corn would, just because the corn would be stressed, right? If there wasn't a lot of moisture. So I'm sure there might be some relationship, but I'm not sure that anyone has really looked at that.
Yeah, that would be my sense as well. And we bring it home, looking at the forecast for October from the drought monitor, and the dry conditions suggest less than adequate moisture for the next planting season. And so that's something suggesting that there might be stressors on the plant right from the get-go. So all these preventative measures would be even more important, yeah, I guess is the point I'm making. Earlier on, I was talking to Fred about, I think it was 2013, when USDA asked me to go and talk to some producers in Croatia. And this was because the government had shut down 300 dairy farms. They shut it down because the milk from these farms had aflatoxin levels that was higher than the EU threshold, and they wanted to get into the EU market. So to show that they were serious, they shut down 300 dairy farms. And as I traveled the country, I was shocked and saddened because it was just drought stricken. And you could see that it was not just this season, but even the following season, they were going to have a big problem. And so we talked a lot about, mycotoxins, binders, and preventative strategies. Thankfully, we're not at that stage. Thankfully, this is happening early enough that I think we can take some preventative measures.
Thank you. Joe Lawrence gave us a tar spot link there with some information on it. Is there any potential issues? We're using cover crops fairly heavily, so we've got rye or wheat coming up in silage acres that did have rust in it. Are we going to see issues in that next grass crop?
A lot depends on the specific situation. If you're using a legume that's fixing nitrogen that's going to benefit the corn, then that's an advantage. A lot depends on the plant spacing. A lot depends on how much of the cover crop you're using relative to the corn. So I don't know that I can generalize. I'm not sure that it's something I would worry about. I think if the best management practices were followed when the cover crop was being grown, then I don't think that would be an issue. That's just off the top of my head.
And if we're thinking in terms of hosts, corn is the only host for Puccinia polysora. So wheat and cereal, rye, oats, those kinds of things, that small grains that might be used as cover crops, are not going to be hosts for Puccinia polysora. They will be hosts for other rust species, right? But as we saw earlier in the presentation, there are a lot of different rusts caused by a lot of different species.
Very good. That's good news. We've got a few minutes left, so if there's questions, go ahead and type them in. I'll throw it open to Dr. Adesogan or any of the other folks here. Any last take-home message comments that you want to stress to the folks listening today?
I think one of the last take-home is we talked about rust-resistant hybrids, but something to discuss with the corn companies supplying corn is, are they resistant? Are those hybrids resistant to southern rust? Because this is not just about, is it resistant to common rust, but is it specifically resistant to common rust? So I think that's going to be a very important question to ask, and to look for those that have that advantage, in addition to being resistant to other diseases, as you look out for your hybrid choices for next year. So I think that aspect, and then talking to your state specialist about planting time, harvest time, scouting, and fungicide application think those would be the core take-home messages. Thank you.
Dr. Max, Allison, either of you want to give a final comment for a take home?
I've just been telling folks in Iowa that remember Southern rust can't survive here. And so 2026, we start with a clean slate that the pathogen will have to get up here to Iowa from the south. And then it will have to get up here early enough, and we will have to have the right conditions for it to cause the type of disease or the type of severity that we saw this year. So I think that's the good news for tar spot, is we start with a clean slate in 2026. That is not the case for tar spot or any of the other diseases that we have.
That certainly makes sense. Now, looking through the list of people attending, we've got some producers from Missouri and Kansas. How far north is Southern rust endemic?
So I think it was Max who mentioned that Southern rust is an obligate parasite, which means it can only survive on green tissue. And so if you do not have green corn in your state throughout the year, then it is not going to survive in your state. So look around you in January and February. If you have any green corn, you could be in trouble. But if you don't, you'll probably, the pathogen won't be surviving there.
And
That makes sense.
You bet. And it's a single host rust. I mean, there's not something else that carries it through the season.
No, it's a single host rust. So you're right that some rusts have alternate hosts, but so far nobody has found another host for Southern rust. So we don't know where those black teleospores that it produces at the end of the season, in theory, they would produce spores that would then infect another host. But we don't know what that other host is. Nobody has ever found that other host.
Well, that's good news for us. Let's keep it as a single host. So, okay, thank you very much, Adesogan, for sharing the information and your insights. I want to remind people that the program has been recorded and will be available on the Iowa State University Dairy Team website. Give us 5 or 6 working days. In addition, I will email everybody who is registered when it is available. And in that email, you also have a link to the program evaluation. Thank you for your participation, and I look forward to seeing everyone at the webinar next month. And with that, I will go ahead and conclude the program.
Thank you all. Thanks very much.